For question number 1, you need to understand, in this case we are talking about X-ray, and this question is simply asking you the intensity of the X-ray beam at point A and point B. So why this one is different? State two reasons other than absorption of X-ray photons in the metal for the intensity at point A to be different to that at point B. So why the intensity at point A and point B will be different? So we need to state two reasons for that. Please think about reasons first of all by yourself, and then I will explain you. Absorption, you no need to consider. It's telling you other than absorption. So you cannot say X-rays will be absorbed by this metal plate. So you cannot write down that in your answer. You need to state other two different reasons. So why intensity at point A? So let's say intensity at point A, this is IA. At this point, let's say this is IB. In this case, I hope you will simply say that IA will be greater than IB, and we need to state why IA will be greater than IB. First of all, let's try to understand in a very simple way. As X-rays are coming from here, some of X-rays, let's say these X-rays are coming, so let me draw this arrow. Let's say this is the intensity of coming X-rays. Some X-ray they will pass through this one, and some X-ray they will be reflected. So first thing you will say, some of X-rays they will be reflected back. So one reason is reflection. So one reason we can say is simply reflection. So what is the second possible reason? One is reflection. So this one you can see there is a change of media, so it means there will be reflection. And the second possible reason can be scattering. Scattering inside means X-rays inside this metal, they will scatter. This is how you can answer part A. Let me go to next now. Very nice question. We have done similar type of question before, and in today's class we will do another question to make sure you have clear understanding of this type of problem. So this is about attenuation. So let me explain you this. So in this case, first thing question is asking you, you need to find out intensity of X-ray beam incident on the specimen and intensity of X-ray beam emerging from the specimen. So in this case, you can simply imagine that, let's say the intensity, first of all, is asking you only about thickness of the muscle. Means we have intensity I naught, this one is coming, and after passing through this one, this is the emerging intensity of emerging X-rays. So we can say this one is I. So this is I naught, this one is I. So we need to find the ratio between I naught over I. So we can simply use this formula. I is equal to I naught e to the power of negative mu times x. We need to find ratio between I naught over I. So in this case, so you see we can find I over I naught from here by just simply dividing by I naught. So this one will be equal to e to the power of negative mu x. But question is asking us I naught over I, incident over transmitted. So we can flip this one. So we can say I naught over I. This one will be equal to e to the power of mu x. And now you can plug in values and you can find the answer. Mu is given to you, x is given to you, thickness of this one is 4 centimeters. So mu has to be in centimeters. So you have to check is the mu given is in centimeters or it is not. If not, you have to change that one. So you see mu is already given in centimeters. So you can see for the muscle is 0.27. Now simply you can plug in values. For this one, simply you can write down here e to the power of mu, that is 0.27, and the thickness of muscle is given, that is 4, and you can find your answer. So this is how you need to answer this problem. So any question about this now, please? Is it clear to you? Let me show you the answer. So this one has to be your final answer. 2.94. This one has to be the final answer. So if you do calculations, 2.94 you will get. So this one is the final answer. So it means incident intensity is this many times greater than transmitted intensity. So this one is the answer. Now let's go to next. Now the second part. Now you need to consider muscle and bone. Mean the intensity, for example, I naught is coming from here and it passed through the muscle, then it passed through the bone, then again it passed through the muscle, and the question is asking you to find the ratio. So in this case I have drawn here. Now you can see this one is the incident intensity. I can simply say this one is I naught. After passing through, this one is the muscle. So let me use a different color to make sure you have proper understanding of this. Let me use this highlighter. So this one is the muscle, please. This one you can imagine that this one is the muscle. So this one is muscle. I draw this one in advance to make sure you have proper understanding. So this one is muscle. This one is muscle. And the next one we can say this one is the bone. So this one is the bone. So we have two different media. So this one is the bone. Now in this case you need to understand intensity is coming. So let me also write down here. So this one is muscle. So this one is muscle. And this one is bone. So this part is bone. Now you need to understand the thickness of the muscle. Bone is 1.5 centimeters. So for this one we can say this one is 1.5 centimeters. How about the muscle? So that will be 4 minus 1.5. So it means muscle will be 2.5 centimeters. And now we need to find the ratio between I naught over I2. So this is what question is asking you to find out. Incident intensity over transmitted intensity, I naught over I2. So this is we need to find out. So how we can find out this one? You can try this one first of all. Take 1 minute or 2 minutes. How you will find this one, and then I will explain you. So please spend a little bit time on this. Then I will explain. This question is very important. If you understand this question, it means any question about X-rays you can answer. Same method we can use for 2 media, 3 media. It doesn't matter how many media we can use for all of them. I want you to try this one first by yourself so you can see where you have problem. So let me explain to you. If you have done, wonderful. If you're not clear, now listen my explanation. So I will explain you this one in detail now. So let me explain to you this one. So first thing, please, you need to understand. You need to find the ratio between this one and this one. So first of all, I will take only this media, means only muscle. So for this one, simply you can say I1, this one will be equal to I naught e to the power of negative mu x. Now if you go to the second case now, means the second media. So we can write down I naught, I2, this one has to be equal to I1 times e to the power of negative mu x. So we can also write down here, for example, this one is for the muscle, you can say this is M. This one for the muscle, you can say M. This is for the bone, this is B. This is for the bone, this one is B. Now the next step. For the next step, we need to understand that I2, this is equal to I1. So I can replace this I1 now with this value. So I will be writing here I naught. So this is the value of I1 e to the power of negative mu, and this is for the muscle, and this x, this one is for the muscle. So this x is also for the muscle. So we can use M here. Very important concept. So this is value of I1. Next one, you have to multiply this one with e to the power of negative mu. This is for the bone, and this is x. This is for the bone. So we can multiply with this. Now you need to further simplify this one. So in this case, we can write down this is I2 divided by I naught. So I can write on I naught. I naught. Let me do in a beautiful way. So I naught. So now what we left here, we have e to the power of negative mu. This is M, and this one is xm, and we have e to the power of negative mu b, and this one is xb. Question is asking you to find out I naught by I2 because incident over emerging. Incident over emerging means I naught by I2. But here you have I2 by I naught, so simply you need to flip. So it means I will write down here that I naught by I2, this one has to be equal to e to the power of this minus is become positive. So mu m xm e to the power of mu b xp. Now simply plug in values and you can find the answer. So simply you need to plug in values of mu is given, x is given, and you can find the answer. These are the steps you need to understand. If you solve this one, your final answer will be 177. So 177. So that is the final answer. 177. So you will get your final answer 177. You can use calculator, you can check right now. I hope this question is clear to you. Very beautiful question. You need to understand how to answer. Any questions about this one at this moment? So your answer has to be 177. You can simply plug in values and you will find the answer. You can see here it is given to you is 0.27 and 3.0. So 0.27 and 3.0. So we can plug in values here. So let me plug in values and make more space for you. Okay, so simply what you need to do now, you have E for the muscle, mu is equal to 0.27 and X for the muscle is 2.5 and for the bone we have this is 3.0 and this is 1.5. Now you can use your calculator and finally you will get your answer 177. So this one is the final answer. So any questions until now, please? So if no questions, I will just go to next now. So let's move on to the last part of this. Now this question is asking you, is it good contrast or not? So in this case, use your answers in one, suggest and explain whether an X-ray image of this specimen is likely to have a good contrast or not. Good contrast or not. Now this is the point you need to understand. For good contrast, we have discussed in our classes, if there is a large difference between the intensities, it means that there is good contrast. The ratio is much less than 1.0, it means also good contrast. So it simply means that if intensity, for example, in this case I'm talking about I2 and I0, if I2, this one is much less than I0, it means there will be good contrast. It means good contrast. So this is one way we can say. If I2 is much less than I0, good contrast. And other way to say this one, we can also say as I0 is much greater than I2, it also means that good contrast. So in this case, we have found that the ratio between I0 and I2, that ratio is equal to 177. I0 by I2, we have found that is 177. It means I0 is 177 times greater than I2. So it means there is good contrast. So that's all what you need to understand. So it simply means that in this part, here will be low intensity. So here will be low intensity. I mean this area, this will stay white. This will stay white. And this one, this will stay black. Because photographic plate is white actually. So this will stay white and this will stay black. So it means there will be good contrast. So simply you can say for this one is a good contrast. Let me clean this one so you can see the full answer. So in this case, simply this is what you need to write down. I hope this is clear to you.